chords today, 10-3. We're going to recognize and use relationships between arcs and chords, recognize and use relationships between arcs, chords, and diameters. So remember an arc, Moya Daniela, an arc was going to be this part here, and a chord was going to be right here. All right, so we're just going to go to that stuff real quick. Well, what's going on? Erase. Okay, so a chord is a segment with endpoints on the circle. So from here to here. Remember that. That is a chord. If a chord is not a diameter, then its endpoints divide the circle into a major and minor arc. So here's your minor arc. And then here would be your major arc, the rest of this circle, okay? In the same circle or in congruent circles, two minor arcs are congruent only if their corresponding chords are congruent. I think this is a typo right here, okay? Shouldn't be like that. So let's look what it says. So if this right here, arc, is congruent to this arc, okay, I guess I'll put a line here like that, right? Then what do we know? Then we know that these chords are congruent, okay? Copy that down for me, guys. We're going to use that right now. It's pretty easy. It's pretty, pretty obvious, you know. If you copy that down, I'll give you about 30 seconds. I would say just get the main ideas. You don't have to go ahead and write every word per word, but make sure you understand. Again, this part is not good. I would not have that line segment part on top. Just a little typo I'm thinking from the book. I'll take some. All of it. Ready, guys? So let's go. Again, the main idea from here is that this part is congruent to this part here. The arcs are congruent. Okay, let's put one line here. When their chords are congruent. And this vice versa, if you think about it. If you know this chord is congruent to this chord, then the arcs are congruent. So we're not going to prove that. We'll just come out here real quick. In the embroidery hoop, okay, you all seen these things that some of the grandmas used to go out here and make some designs with their, I'm sorry for saying grandmas. Did you know a lot of pro athletes do this too? Diego, did you know that? A lot of pro athletes use this stuff here. Do you know why? To calm their brains down. Because you got to concentrate on each little loop. This may be like a little puzzle or like that. So they actually do this to go ahead and calm their brains down so they can get more focused, more relaxed, lose track of everything that's going on. So in the embroidery hoop, here we go, line segment AB, so you can say that's a chord, right? AB, from here to here, is congruent to line segment CD, and that shows you here with that little one line. And the measure of arc AB, AB is 60, so it's 60 degrees, right? 60 right here. Find the measure of the arc of CD. So that's like a no-brainer. Since this chord here is congruent to that chord here, this arc that is, same thing here has to be 60. So there it is. Going once, going twice. Anybody get lost on that one? It's too easy, right? I promise. It's an easy section. Pretty good. Thank God. Guys, this is one of the last sections that we'll use or start covering. Actually, one of the last chapters. We're already in chapter 10. We're going to start maybe getting ready to review for the star. So help me out. Let's go ahead and do number 1. Copy this. You don't have to put the little figures here, whatever these roses or lilies or I don't know what they are. And we're going to go and find the measure of arc CD. Okay, here they're saying the measure of the arc is 78. What is this arc CD? Okay, guys, so while you do this, you don't have to draw everything, but do remember that you're just saying that these things are congruent. So on the side, you write same congruent. So when you go to college, you want to know why these notes are there. You're trying to prove or show that these things are congruent. Now, you got to make any notes that make your life easier. Cool? So I'll let y'all copy it down. Let's go and see what the answer is now. So the measure of arc AB from A to B is 78 in the embroidery hoop. Find the measure, more baby, find the measure of CD. So in this situation, we know that this arc that kind of makes AB, and then this arc. This chord here that makes AB, this chord here that CD makes this arc CD, also has to be 78. So we'll just put here, the measure of arc CD, 78. Cool? The reason is because the chords are congruent. Let's move on. Do you have any questions there, guys? Nah, right? Pretty easy. Okay, so now, obviously, they always kind of throw algebra in here to kind of make it, very basic in the beginning, then we'll make it a little more interesting. So in the figures right here, you see circle J is congruent to circle K. So these circles are congruent. You got it? So like everything's congruent. You see, I don't know, we don't talk about their diameters, their radius, their areas, their circumference, whatever, they're congruent. And the measure, and the arc MN is congruent to PQ. MN is PQ. Okay, so I can see that with that one little line right there. Find PQ. Okay, so you got to kind of look what's going on here. In this terms, they didn't give you numbers to work with. They gave you like an algebra expression. Well, since I know that arc is congruent to that arc, this chord here happens to be congruent to this chord here. Since those things are congruent circles, that arc is congruent, so these chords are congruent. Now we're going to say, well, 2x plus 1 is equal to 3x minus 7, and solve for x. We need to know what x is. So we can go and plug it into this one right here to figure out what PQ is. You got it? And that's it. Let's just do the math. They actually did the math here for us. I guess I can do it here. I would minus 1, right? Minus 1. No, I wouldn't do that. Try my eraser. Oh, plus 7. Plus 7. That gives me what? Gone. 2x plus 8 is equal to 3x. Minus 2x. Minus 2x. We'll go with 8 is equal to x. So if you say that's your answer, you kind of got lost in the question because we want to know actually what's the measure of PQ. PQ is in regards to x. So we'll come out here and plug it in, and we'll go with 3x minus 7, 3 times 8 minus 7, 24 minus 7, 17. How do y'all feel, guys? Not too bad? Anybody have any questions there? Yes, no, maybe so? Come on, talk to me. Fabian, you showed up a little late. You okay, brother? Ooh, he just logged in and went back to sleep. Brother Fabian. Brother Fabian. Okay, we'll move on. Let's go and try 2, guys, right here. So in circle W, here's circle W, arc RS is congruent to arc TV. Brother, you need to work out, bro, so you can go to sleep early. Okay, try to eat healthier, baby, okay? I know how you like to snack it up, bro. RS, which is this part. It's kind of weird, but that's RS. And goes to this one, okay? So that goes to that one, and this one goes to that one. Find RS. It's kind of like the same idea. Okay, I'll let y'all get a couple of seconds to copy it down, and then we'll work it out together. Guys, if y'all don't mind, I'll put some jams on. That'll be in the background. My neck. Okay, anybody know how to approach this one? Anybody know what to do on this one? Can somebody humor me and just say, "Hey, what you do? Yay! It's so fun!" It's so hard being myself, guys. I'm over here by myself, all quiet, no students say anything. Thank you, Eileen. Eileen, man, guys, Eileen, on fire. She's always commenting, helping me out. Excellent. So we're going to go 5x minus 9 is equal to 2x plus 3. In this situation, you want to look at this. I'm going to prove it or show it to you how you're supposed to think of this one right here. This arc is congruent to this arc, so that means that this chord is equal to this chord. And like Eileen put it, I guess the dimensions is in terms of x. The length in terms of x, we're going to put that one equal to the other one to give us the x, I guess, comma x, right? So plus 9 minus 2x minus 2x. This gives me 3x equals gone 12. Divide by 3, x is equal to 4. Y'all don't mind? That's almost my answer. Now let's just plug it in because it wants to find RS, right? Oh, what happened? They want to find RS. So in regards to RS, we're going to come out here. RS is equal to 5x minus 9. And we're going to go here and go 5 times 20. Substitute. Oh, my bad. 5 times 4, right? Minus 9. So in this situation here, we'll go with 20 minus 9. We'll go with 11. Question now, guys. Pretty easy. It's pretty easy. It's pretty cheesy. Okay, I'm going to go slow because my other device logged out. It's not cool. Guys, do y'all still hear me? Let me see if I'm still here. Yes, awesome. Isabella, thank you. Eileen, my thing logged out. She was. Okay, well, let's move on. Okay, so here we go. Bisecting arcs and chords. Okay, bisecting arcs and chords. If a line, segment, or ray divides an arc into two congruent arcs, then it bisects the arc. If that makes sense. Okay, so let's look at this real quick. If a diameter or radius of a circle is perpendicular to the chord, then it bisects the chord and its arc. You got to see what this thing is. If it's going to show you that this right here, chord, and this radius, this diameter, are perpendicular, then this part is equal to this part. This part here is equal to that part. Pretty cool or what? What do y'all think, guys? Can I get an amen? Okay, I really can't see them like the chat. Let me move down. Let me see all the amens. Hey, morning, Mariana. Your mic is on. I can't hear you, but I can see that it's on. Okay, no amens. It's all cool. It's all good in the neighborhood. Okay, the perpendicular bisector of a chord. Let me go read the next one, right? The perpendicular bisector of a chord is a diameter. And move it up. I'll use this one. So here it goes again. If you see that it's perpendicular and you see that it's bisecting, like this section is equal to this section here, then this here is a diameter or a radius. That's pretty cool. That's pretty sweet. Does that make sense? Okay, go and copy both of those guys so you don't mind. Very important idea. We will use these. Very important idea. Very important idea. Copy them down. Again, this one says, if you see that this line here is perpendicular to that one, then you know it bisects the chord and it bisects the arc, okay? Now, in this other one here, if you see that it's perpendicular and bisecting, then you know this is a radius. Well, what do you mean, sir? Because we could have this set up like this, right? And we have a line running right next to it, but it looks like it runs through the center. And we see that these two are not equal, then that's not a radius, that's not a diameter. But if we don't have the center marked off, and we have a line running through it, how about, let me draw the chord first. And we have a chord here, and we have a line running through it. It does not show us the center is not there. And we see this, but then now we know, we also see this. We see that it's, you can kind of, what's bisecting, congruent, perpendicular bisector. Now we know this here, cha-ching, is a diameter slash it is a radius. Pretty cool or what? Amen. Copy that down, guys. Give about 2 minutes, please. It's a lot of good information there. Actually, it's so good, that information. Jeez. So I had to restart my iPad, guys. I'm going a little slow because my iPad's not showing me the chat. I do not know what in the world is going on with it. Okay, guys, y'all ready? Let's check this out. Let's move on to the example. Let's see what's going on here. So for the example here, it's going to go on to this perpendicular bisector slash gives you the radius, or tells you it's a radius, tells you it's a diameter. Okay. If not, if they show you that it's perpendicular, then you know it is going to bisect it. So it's vice versa. Either way, it goes the same way. I'm back on, guys, with my chat. Come on, chat. Okay. Can somebody say hi real quick? Make sure the chat's working, please. Somebody. Thank you. Thank you, girls. Appreciate it. Okay, so in the circle S, arc PQR, so it's giving you direction, so we're going this direction, is equal to 98, all right? Find the measure of PQ. Okay, PQ is right here. I want you to say this much. It told you right now, if you saw that it was right here, this thing going to the center, and it was perpendicular to it, then it bisects this part and this part. And it bisects, you can say the chord also. He's asking about the arc. I really just care about the arc, all right? So I'm going to come out here. Knowing that from here all the way to here is going to be what, 98? Well, if it bisects it, because it's showing you here that it's perpendicular, once it shows you that it's perpendicular, that means that it cuts it in half. Then we can basically say, well, we need half of it, because PQ is half divided by 2. I'll look over here for the math. Oh, that's 49 here. 49, the measure is 49. Yeah. Not too bad. Pretty easy, right? It's pretty easy, I promise. Don't freak out. Okay. Now let's try in circle S. Copy that down real quick. Find PR. How does that make sense? Do you see what PR is? I don't see PR. Oh, they give me information here. Okay, you need to use that 6. Morning, Joy. Good morning, Joy. Glad you could join us, brother. 30 minutes late. I don't want to call your mom. I'm joking. Just show up earlier, man. You missed the whole discussion already. Cool? Can I get a cool? Yes. Okay, sir. Yes, sir. Maybe, sir. I'll try, sir. Oh, okay, yeah, don't worry about it. I'm sorry, brother. I'm sorry. Internet problems is horrible. Give me time to copy it down, guys. So let's look at this one. Ready? So this whole circle here, it's showing me that this line here is perpendicular to this line. Once you see that, you can't forget that this side is equal to this side here, and this one's equal to this one here. Okay, in this situation, they gave me from here to here. They gave me this distance, right? We know that's 6. Well, what does this one have to be? Also 6. And the question is asking, what's PR? What's the distance from here straight across to here? Well, isn't it 6 plus this other 6, known as 12? Thank you, Eileen. Pretty easy, right? Yeah, so today's lesson is going to be pretty easy. Today's assignment, I only gave you 5. How many do I want, 5 or 10? Should I maybe make it 10? Too easy, right? I wonder what I should do, 5 or 10? Okay, I'm joking, I know y'all like the 5. Here we go. In the stained glass window right here to the right, you see it? The diameter is GH is 30 inches. So from here, it's showing you going to the middle. Across is 30 inches. And chord KM is 22 inches. So let's look at KM. Where's KM? From K to M. Okay, so wait. From here to here is 30. From here to here, I guess I'm already here, so I can keep track. 30. KM is 22 inches. From here to here is 22. Find JL. Where's JL? From here to here. Okay, this is not too bad. I can see it. Actually, you're not here. Let me just show you what they're asking you to do. So from here, if you think about this, from here to here is 30. Do you agree? Okay, so that's 30. So from here to here is 15. But just guess what else is 15? From here to here's 15, here to here's 15, here to here's 15, here to here's 15, here to here's 15. How do you get that, sir? Well, the distance from the circle to the center is 15, right? The distance all the way across is 30. So all these things here are what? 15. The radius is 15. So I'm going to purposely leave that one right there. Okay, if you don't mind, I'm going to leave from here to here, which is a radius. So that's 15. Now, if you kind of look over here, from here to here is a radius, but they want to know from here to here. What do I know here? Well, I know from here to here is 22. It's showing me that it's perpendicular. So this one happens to be half, and this one happens to be half, so this one's 11. Do you make sense? Does that make sense? Can you see it there? So here's my right triangle right here. That's this part right here. Up and down. Here to here is 15. Here to here is 11. Right angle here. And that question's asking from here to here, right, from J to L, from J to L, what is that measurement? Look what I have here. What should you automatically think, guys and girls, when you see a right triangle? Please, somebody tell me. Somebody tell me, when you see a right triangle, what should you automatically think? Very good, very good, very good. And the bonus points goes to... And the bonus points go to A squared. Awesome. Finish it up, Isabella. A squared. And what else? A squared. A squared. Almost. Plus B squared. Good job. Equals C squared. Good job. Bonus points for Isabella. And that's what you think. The only one that you need to be worried about is that this one from here is not, okay, well, let's see. Basically, C is this one across, right? So that has to be 15 here. And then we'll go with A to be 11. 11 squared plus B squared equals 15 squared. And that's how you work these out. What do you think about that one? Diego, help me out, Diego. What do I do at this moment right here? What do I do at this moment, brother? And solve that, brother. Okay, so that's the way they're going to set it up, too. See, a squared plus b squared equals c squared. Do the math. They got about 104, square root of 104, about 10.2 inches. Okay, again, we set it up as the right triangle. A squared plus b squared equals c squared. The idea behind this one, guys, is that you have these things perpendicular, / they bisect each other, radius, diameter, all this stuff. It's pretty easy, but not too hard. Okay, let's try this last one right here. Oh, we need to do one more. Okay, let's try this one, right? Encircle R, find TV. Okay, R, find TV. So copy that down real quick. So on these guys, you got to be like little detectives. You got to figure out, okay, what's given to me, what's going on, how do I do this, where am I at, all this good stuff. Okay, copy that down, guys. Copy it down. So I want to start looking at this. I'm going to start breaking it down. They want us to find TV. They want us to find from here to here. I have no idea what in the world that is. I'm not going to idea. I can't see it in my head. So I'm going to try to figure it out. Well, I know this part here. 6, 5. I don't know this one. So if I know this one here, then I know this one here, right? Okay, so that's what I'm going to kind of look at. Anybody know what to do on this one? I haven't eaten breakfast yet, so I'm kind of stumped. Anybody know what to do? Just FYI, guys, it has to be like this, okay? It has to be like this. Anybody? Anybody see it there? Because I'm going to tell you how I would approach it. You see this? I want to make that right triangle right there. I want to make that right triangle. So if you don't mind, I'm going to go from here to here is this distance from here to here. You okay with that one? And then down here would be that one. So I'm going to try to figure out this right triangle here, if you don't mind. Right angle here. You see right angle here means it's right angle here. So in this situation, I know this one's 6. Thank God. Do I know this one from here to here? Does anybody know from here, from R to V? Think. Anybody know from R to V? Oh, yeah. Good job, puppy. This one right here. And this situation from here to here is the same thing from where? Nowhere, right? From here to here. But the distance from here to here, you see that distance, is the same thing as from here to here. In that situation from right there to there, that's 11 because this is 6 plus 5, 11. So from here to here, 11. So now I have my a squared plus b squared equals c squared. In the situation, you do better, remember that's 11. That one over here is, I don't know, A or B. I'll go with A, B, and that's going to be a C. So set it like that. A squared plus 6 squared equals 11 squared. I don't know what to do now. I forgot and solve it, right? My gosh, my eraser's killing me. It's not working. I don't know why it's not going on. So what you do here, a squared plus 36 is equal to 121. We're going to minus 36, minus 36. So we're going to have a squared is equal to 121. Anybody know 121 minus 36? Anybody can do that one? That becomes a 9, or 11, right? 11, 5, 11 minus 85. So we're going to get the a squared equals 85. Get the square root of that one, square root of that one. We're going to go with a is equal to the square root of 85. And I'll leave it there. I'm going to leave it there. I'm not going to move it. I'll just leave it there like that. If you think about that one, I think about a 9.1-ish. How do you get that, sir? Because 8 times 8 is 64. 9 times 9, 81. It's just slightly bigger than 81. So it's about 9.1-ish. Approximately 9.1-ish. Okay, let's come out here to the last section. This is the last thing, I promise. Try to take 5 minutes and you're on your own. In the circle, okay, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so this is what this says. From here to here, from the distance from the center to this chord, if it's equal to this one here, this distance is the same thing, then this chord here is equal to this chord here. And it has to be the same, guys, because you think about the curvature. If you could put a piece of plywood here, it'd be the same distance away if you could have like a plywood or a board that would sit as far as away it could from the center, regardless of where you put it. So let's read this one again. If FG, line segment FG, is congruent to JH, these two are congruent. All right, let me just put a line here. These two line segments are congruent. If and only if LX is congruent to LY. LX is congruent to LY. Copy that down real quick. We will use this one right now. Maybe about 3 more minutes, guys, and then I'll let you all work on your own. Do you have about a 5-question little practice thing here? Come on. Y'all ready? Copy that down, guys. Copy that down. Okay, let's move on. Try it up. Okay, so I'm going to explain this one, and then you're free to go do your work, okay? Now, if it looks equal, they're probably equal, just FYI. And in circle A, so this circle here, WX is congruent or equal to XY. Where's WX? WX is equal to XY. Okay, so in that situation, you better realize they're saying this chord here is congruent to this one here. They're congruent. So that means they fit equal distance. You see this? My erase is killing me, not working. That means that this distance here is equal to this distance here, which basically means 5x is equal to 3x plus 4, right? So find AB. From A to B, well, first off, I got to find x. So I'm going to set these two things equal to each other, like I just showed you right here. This one is equal to that one. Now, x to be 2, plug it into which one they wanted to find, AB, plug it into AB. And actually, it doesn't even matter which one you plug it into because they're both equal to each other. Pretty cool, or what? Are y'all ready or what? I'll work this one out, and I'll leave it on projecting, and y'all can go work on your assignment, okay, guys? So in circle P, PQ, where's PQ? PQ is equal to 3x, so from here all the way to here is equal to 3x minus 4. All right. RS is equal to 14. RS is equal to 14. Okay, pretty cool. Well, guess what they show me here? They sneakily show me another way of showing that two line segments are congruent. See, from here to here, it's showing me that it's 8. From here to here, it's showing me that this is 8. So now that tells me that 3x minus 4 is equal to 14. Those two things are congruent. So I'll set them up and do that. So I'm going to go with 3x minus 4 is equal to 14. I'm going to add 4. This gives me 3x is equal to 18. 3x equals to 18. Divide by 3. Divide by 3. X is equal to 6. Cha-ching. Did I get the answer? Oh, actually, I did. Question on that one, guys and girls. What do y'all think? I got to hear that jam again. Really good. Questions or anything? Any questions, guys? Anybody? If not, okay, let's get busy on Alex. You have an assignment. Kept it short and sweet. It's 5 questions. And the questions are honestly kind of like this one right here. It'll be called 10/3. Cha-ching. Okay, guys, do me a favor, get it done. I am going to be here in the background, just chilling. Actually, I need to do some stuff.